Now let's talk about file objects, about their types, then about reading and writing to files, and end up using them with the context manager. We are all familiar with the files. These are named areas in the permanent memory of our computers, which are controlled by operating systems. From a Python perspective, files are a special data type that gives access to operating system files from our scripts. To create a file, I have to call the open function, and as the first argument, I have to pass into it the file name or path to the file that it should open. Let's name it readme.txt. I am passing the file name in quotes because it's just a name of a file, a string. Otherwise, Python will think that this is a variable and will start looking for its definition. Let's hit enter. And immediately I got an error message, the exception that the file was not found. This is due to the default behavior of the open function. By default, the open function opens file for reading. So it tried to find the readme.txt file and failed to do this. And this entry is equivalent to this one. I'm calling the open function again. I'm passing the file name and the mode parameter equals to r. In this expression, I assigned the r letter to the mode parameter, and the r stands for reading. And the whole expression says that the readme.txt file should be opened in read mode. Usually, the name of the mode parameter is not indicated and the arguments are passed by position. Since the mode parameter is the second in a row, the read mode is set for the open function by default. If the second argument to the open function will be w, short for the writes, then Python will try to find and open the existing file for writing. If it doesn't find one, it will create it. Let's save the result to the f variable and hit enter. And we can see that the readme.txt file was created. The file is empty. The open function creates and returns a file object, and using the methods of this object, we can, among other things, read the content of the file and write to it. I assigned the created file object as the value of the file variable, and as usual, let's take a look at the type of this object. Type file. Please note that the data type of this file object is text IO wrapper. What does it mean? Letters IO tells us that there is some input-output operation. Input-output suppose that there is some kind of interaction between some subjects. One of them sends data, output, and the other receives the data for some processing, input. All of our interactions with the computer is one huge ongoing input-output. For example, I am now saying something into the microphone and the computer writes it just to the file. From a computer point of view, what I am saying through a microphone is an input that is received by the machine, processed somehow, encoded, and then written to a file, output. And there are three kinds of input-output in total in Python. The first one is the text input-output. The second one is binary input-output, or so-called buffered input-output. This is actually any non-textual data. I'm talking now and you are watching the video, it's all binary data. And the last is raw or unprocessed input-output, also called unbuffered input-output. In 90–80% of all cases, we have to deal with the text and binary input-output, or roughly speaking with the text and binary files. Text files are simply a sequence of characters in some kind of encoding like Unicode. Binary files contain data in exactly the same form in which they are stored in the computer's memory. Accordingly, the name text.io wrapper tells us that it is a wrapper over text.io, text input output. That is, it's just a text file. By default, the open function opens files for reading and as text. The W flag I passed into the open function is also used to write only the text data. The RB and WB flags are used to read and write binary data. We will return to these file types and binary data a little bit later, but right now I want to show writing data to a file using a text file as an example. So, to write something in a text file from a Python script, I have to do the following. First, I have to open a file. Let's say it will be our readme.txt file. We have already created it, but I'll do it one more time. To write data to a file, we have to use the write method. File objects have this method. You can verify this by passing the file variable to the dir function. I'm just calling the write method. And then I'm passing some string into it. Hello world, for example. I hit enter and the write method returned me the number of bytes that it wrote to the file. And if I open right now the readme.txt file in a text editor without closing my working session with the interpreter, then we will not see anything. Empty file. Why? This is because by default output to files is always done using in-memory intermediate buffers. How it happens when we edit text in text editors? Everything that we write in the editor is located in the computer's memory, RAM. That is, at the time of writing text to a file, it doesn't immediately go to disk. And to write the changes, you need to push the buffers to disk. And this only happens when the file is closed or when the flush method is called. In order to save our changes to disk, the files must be closed using the close method. So I want to open my editor again and I want to close the file and I'm closing the close method and hit enter. And editor says that the readme.txt changed on disk, reload. And now I got the hello world string. Calling the close method breaks the connection to the external file. Closing files also frees up memory. This can be quite sensitive if the files are large and there are many of them. We don't need memory leaks. Therefore, it is advisable to close the files even after reading. The flush method that I mentioned pushes the output buffers to disk while keeping the file open. Another common file opening mode is A, short for append. This mode appends the data to the end of the file. The difference between W and A writing modes is that W mode will overwrite the content of the file, and in the A mode, new data is appended to the end of the file. So I want to reproduce what I did in the console in my Atom editor. I created the main PY file and now let's do the same. I'm calling the open function. I need the readme.txt, W flag, file write hello world, and the file close. I will call the script for execution several times, and let's look at the contents of the file. 1, 2, 3, 4. The result is only one line because the content is overwritten every time. With the A mode, append, the result will be different. I will also execute the script several times. 1, 2, 3, 4. And as you can see, the result is different. Every time I call the script for execution, a new hello world was appended to the end of the file. And by the way, about closing files, Python automatically closes files when the program exits. Okay, how to read files? Suppose we need to take the contents of a file and write it to a variable so that we can somehow work with it. It seems that the open function creates a file object, and it seems that it is already possible to work with this in our programs and scripts. Yes, but no, not really. The fact is that a file object is not the bare content of a file. It is a Python object that contains a bunch of other service information and information about the methods associated with this object. To get to the contents of the file, that is, to read the file, we need to use the read method. I am opening the readme.txt file for reading. Then let's create the data variable, and I'm calling the read method of the file object. Let's print the data variable and let's run the script. And we can see that the value of the data variable is this text, hello world. The read method reads the entire file. There is also a relatively important method readLines, which allows you to read the entire file too, but it returns a list of lines. Why did I say that the readLines method is relatively important? Because it makes sense to use a file object iterator instead. This makes a lot of sense when dealing with the huge text files, like logs, for example. In order not to gobble up a bunch of RAM trying to load the entire file into memory, it definitely makes sense to read the file line by line. This is a separate topic and we'll get to it if I don't forget. I think we are done with the reading and writing to files, and now I propose to return to binary data and binary input-output. And that is why I dwell on this in such detail. The trick here is that for different data we have to use the corresponding file objects. Otherwise, if we, for example, try to write a picture to a text file, then there'll be an error. And I want to demonstrate this. I've got a picture, a file, image file, milk, for example. And suppose I want to make a copy of it. So I want to save the file name of the picture into the pic variable. It will be milk JPG. Then I want to try to open this image file with the default parameters of the open function and read its content. Pic file variable will get the file object pic, and I'm calling the read method. And I got an exception that says that Python can't decode the bytes data type at this address because it is not a string. So we can't even read the binary data as text. Okay, let's open the file as binary and read it. Pic RB, read binary. Okay. Then let's try to save this opened binary file into a new file that will be opened with W flag as a text. New file. I'm calling the open function again. I need a file name, copy, plus the peak and W as the flag. And now, if I call the write method of the new file object and pass into it the peak file variable, the binary data, then I will get a new exception. New file, write peak file, and I hit enter. Type error. Write argument must be string, not bytes. And it's because it is not possible to write binary data into a text file. The write method awaits a string, but not bytes type. And only after I open the image file as a binary, like this, and try to write it to the file as binary also, only after that everything will work. To get the file, I have to close the file object. Original milk, copy milk. These were the main methods and modes for opening file objects with which you have to work in the vast majority of cases. Now the with context manager. Python has a special with keyword. It is a so-called context manager. It's a special syntax that closes files, but not only files, automatically. The syntax is the follows. We have to use the with keyword. Then we have to call the open function with the W flag, for example. Open readme2 with the W flag. And then we save the opened for writing file object into the file variable using the as keyword, as file. And then we call the method inside this context manager. And after I hit enter, the file will be created. And it is clear that the file object has been closed, the output buffers have been pushed to disk, and we can see the contents of the file. How the context manager works should be discussed in the object-oriented programming topic, and only after the concept of generators has been mastered. More on that later. If you like the video, please leave a like and subscribe to the channel. Thanks for watching.